later on. But another very important thing about it is what we're going to be doing is welding this material through the vacuum forming stage. So that's why I'm in the sink washing it. But what you want to do is use an industrial cleaner like Fantastic or Spray 9 or any of these biodegradable cleaners. You spray it on, wipe it all off, work the soap in very well. If you have any ink or paint on it, you do use acetone first, but then you have to wash it. You don't want to leave acetone on the project because acetone will leave a film and that will detract from the seam integrity. And then after you wipe the soap on, you rinse it off very well with clear water. Until it's squeaky clean. The trick to any kind of welding, whether it be plastic or metal or any type of material you're going to weld, is cleanliness of the material. If the material is not clean, you're going to risk the integrity of the seam in the back. And that, when it's done properly, happens to be the strongest part of this prosthesis. And that's what we're ensuring by keeping the material clean. Now, when you go to put it in the oven, you don't want to have any silicones or any powders in the oven at all, because anything that touches the material while it's heating up is going to get on the material and again detract from the integrity of the seam. So we have a, in fact, let's use the other oven. Let's use the computerized oven here. Okay, you look inside the oven, it's got to be clean. We'll show that. No silicones, no powders, no nothing. This is a product that we have available at the Ortho Remedy called Temploglass. It's a porous Teflon coated fiberglass which will allow air to pass through the material and it won't trap the air as it's heating. Okay, we like to use it because you can put the plastic in the oven once and leave it there until you're ready to form it. What was that, 1/4 inch we're doing? Yeah. Okay. Now, if you believe that, would you be interested in the chainsaw? Okay. Now we'll lay up.
Oh, I just
Okay, that's right. You can cut that. You go up?
I'm okay.
So we've removed the insert. Now we're ready to lay up this prosthesis for vacuum forming, okay? So the model is already loose on the mandrel. So we're going to slide it right back up. This is the point where we calculate the length and the size molding cone that we're going to choose. This particular patient happens to be 18.5 inches to the patella tendon without the shoe. But that doesn't really matter right now. What we're really going to calculate is where we're going to position this model on the mandrel. Since we're using a piece of material that's standard 24 inches long, we want to have 24 inches from the end of the mandrel to about the top of the model to maximize the amount of pylon surface that we're going to form. So right now we can move it up another 2 inches or so. And you'll see on this model, you'll find on the mandrel sometimes there will also already be holes in the mandrel because we're going to have to drill a hole in this mandrel in order to prevent the model from sliding off when we extract the prosthesis. So we look for a spot. You may not find one, we may find here. That's a little high though. Let's see where we are. We'll make that. See if we're any lower. Can you see that hole in there, Frank? Or maybe not. See the hole that's already existing? We're going to utilize it. So the next step now. What is the next step? See if I remember. The next step is retaining ring. This is the retaining ring that's installed on the mandrel first, okay? This is put on the mandrel so that when it comes time to extract the prosthesis, the model is going to stay on the mandrel and doesn't come with the whole project, so you don't have to chip it out. All right, so you put that on first. And since the hole is already there, we'll put a nail through it. And that nail is just to keep the retaining ring from sliding off the mandrel too. That'll clip it off. And then we're going to bend it over. There, that goes there. Now, the next step is we want to clean this mandrel. There'll be a little bit of plaster mud from it from sliding the model up. So you want to make sure it's clean so that this way everything is to within our tolerances. After that, again, we have to put a piece of nylon over the model so that we ensure the vacuum forming. Tie it off over the retaining ring. That black tape in. Now you may be questioning me now, because the insert's now going to go over all this. And what will happen at the end is the insert will retain a little bit of an image from the retaining ring and the nail that was imprinted. But at the end of this thing, it gets plugged up anyway, so you won't feel it or see it. Okay, now the insert can go back on the model. Now I need someone to hold this model. Come around here, Rick. Stay over there. Just remember, this guy's got some deep skin cavities there. And all set. Okay. Now the time comes when we select the retaining ring. The molding cones. These are the molding cones. They come in 3 different lengths. This is a 3.5, this is a 2.5, and this is a 1.5 inch length. The molding cone length is determined by the amount of ultimate cylindrical pylon you want exposed on the prosthesis. For example, you want a minimum of 2 inches of exposed cylindrical pylon. That means the amount of pylon area that's outside of the foot clamp and before this conical transition. A minimum of 2 inches you need, and usually a maximum of about 5 to 6 inches. But then you can calculate the amount of cylindrical pylon depending on how much pylon flexibility you desire for that particular patient. Now this particular patient we're working on happens to be about 200 pounds and very active, but he's also got a 7-inch residual length, if not more, and he's going to be wearing suction, so that's going to take up some extra area. And he's only 18.5 inches from the mid-patella tendon to the floor. So that doesn't leave us with that much.